Hello there, Mr. Sutton here, bringing you the Algebra 2 7-3 lesson on multiplying and dividing rational expressions. If you're doing this as the CP course, this will be a two-parter. For the honors, we'll do this in one part. Specifically, we're going to be simplifying rational expressions, especially standalone ones, and we will be multiplying and dividing rational expressions. For most of the problems you're going to see in this lesson, you're going to be asked to simplify a rational expression. What does that mean? Simplify in this context means that we want one fraction, so if there's multiple fractions, they need to be combined in some way, and also no common factors between the numerator and the denominator. So if we meet these two conditions, we are considered fully simplified. One of the main mechanisms we use to simplify fractions is by doing something called canceling out common factors. Now, what does this actually mean? Because a lot of people, they think of canceling and they just think, oh, I'm going to cross things off. When we're talking about rational expressions, canceling means dividing a factor by itself. That is what canceling is. It's actually division by something by itself. So that means that we can only cancel things that we are able to, that first off, they have to be factors. And if we're dividing them by themselves, that means we need to be able to unmultiply them into their own fraction. So you can only cancel if you can unmultiply a factor into its own little island of insanity. So as an example, let's say that we have 3x over 5x. Now, since 3x and 5x, we have 3 times x and 5 times x. Since those are being multiplied, I'm able to unmultiply them. So I can actually split this up into 3/5 times x over x. And if we doubt this, let's just remember how we multiply fractions. We multiply just straight across, right? So we could multiply this back into 3x over 5x. Now, since I've split these up, x divided by x, what's that? Oh, that's just 1. So this is just 3/5 times 1, which might as well just be 3/5. So these x's here, you can kind of just, in the very beginning, cross them off, pretend they don't exist, because you're just multiplying 1 by something, and then just write 3/5 right away. This is the quick canceling out sort of way of doing it. This is the proving that canceling out works sort of approach. So if you can unmultiply things, we're golden. What if you have another situation like x plus 3 over x plus 5? Well, in this situation, x and 3 are not being multiplied together, so I can't unmultiply these x's into their own fraction. So this is a situation where we cannot just cross off the x's. Now that we've had a little discussion about when we're allowed to cancel and when we are not, let's see if we can use that to help us simplify this expression. So simplify again means one fraction. We can check that off. We've got a single fraction. And also no common factors. So one thing that people are really tempted to do if they haven't really learned about canceling before is they just want to cross off like these x squareds here. But we've seen that we can't multiply these x squareds or unmultiply them into their own fraction. So we know we can't do that. Instead, before we do any canceling, we are going to want to factor before that canceling. And I mean, we know that canceling involves dividing common factors by themselves. So in order to get those common factors, you need to kind of factor in the first place. So with that in mind, pause the video, see if you can remember how to factor these sorts of things, and cross off any common factors you find to simplify this thing. All right, let's see how that went for you. So in the numerator, we are looking, this is just a 1x squared situation, so we're just looking for things that multiply to negative 12 and add up to negative 4. Well, 1 and 12 doesn't work. 2 and 6 works if we have positive 2 and negative 6. So x plus 2 and x minus 6 will do it there. In the denominator, we have a difference of perfect squares. So we can actually square root both of these and use a plus minus parentheses. So that'll leave me with x plus 2 and x minus 2. All right, so we've fully factored everything. Are there any common factors that we can cancel out? Well, yeah, these x plus 2's. If we wanted to, we could put these in their own fraction, divide them by themselves to get 1, so we're allowed to cancel those out. That leaves us with x minus 6 over x minus 2. And half the battle on these problems is to quit while you're ahead and not go too far. Some people get to this point and they want to cross off these x's, but again, We cannot do that for the same reason we could not cross off the x squareds in the beginning, because these can't be unmultiplied. There is one other thing that we do need to do at the end of this problem, though. It's a little bit subtle, but the problem that we have right now with just leaving this as the answer is that this simplified expression is not exactly the same as what we started with. To be exactly the same, to be equivalent, as we say, it would have to have the same behavior. It would have to do the same thing with all possible x values that the original does. Now, this simplified works for most x values, but there is one little exception. If we were to plug in -2 to the original function, we would get 4 minus 4 in the denominator, which would be 0, and that would be a problem. So -2 doesn't work for the original. But if you plug -2 into the simplified version, -2 minus 2 here does not give us 0 in the denominator. So the simplified would be okay with -2, the original would not. And unfortunately, that's not okay. We need to make sure that the simplified has all the same dietary restrictions that the original had. So if there are kind of hidden, undefined pieces in this simplified that got canceled away, we need to explicitly tell people not to plug those in. So to sum that up, values that make the original but not the simplified expression undefined must be excluded. And you can find these pretty easily if you just look for factors that got canceled out. So in this situation, we would write x does not equal -2, and that would give people all the information they needed to safely use this simplified version. For this next problem, we are trying to simplify a product of two rational expressions. So one way to do this would just be to multiply these out right off the bat, numerator times numerator, denominator times denominator, and then you could simplify it kind of like you did the last problem, canceling out common factors. But sometimes that's the long way around. It's often much quicker if you can cancel things out before you multiply, because that's going to leave you with less to multiply. And when we're doing this, we might be wondering, well, is it possible to cancel out things that are in different fractions? If I have, for example, like this 8 and this 4, could I cancel these out? Even though they're in different fractions, we've got 1 in the numerator, 1 in the denominator. And it turns out that yes, when you are multiplying fractions, you can cross-cancel factors that are in different fractions, as long as one's in the numerator and one's in the denominator. The reason behind this is that if I were to multiply these two fractions together, then the 8 and the 4 actually would be in the same fraction. 8 would still be in the numerator, 4 would still be in the denominator, so you could cancel those out anyway. So this cross-canceling business works great with multiplying. It does not work if you are dividing, adding, or subtracting the fractions, because multiplying is the only one where you're moving the numerators in together and the denominators in together. So with that in mind, use it or don't on this problem, totally up to you, but pause the video and see how far you can get simplifying this. All right, so I'm going to go ahead and actually try to cross-cancel a few things. Let me look at my numbers first. I have an 8, a 7, a 2, and a 4. So I know the 8 and the 4 can definitely be reduced, but also the 8 and the 2. In fact, 2 times 4 actually is 8. So this is kind of like having an 8 over 8. So I could cancel the 8, the 2, and the 4 all out in one shot. And I'm feeling pretty good about myself now. Let me look at the x's as well. We have an x cubed up here and an x down here. If I just cancel those out, reduce those, that's going to leave me with an x to the 3 minus 1 upstairs, so x squared up there. And then looking at the y's, I have y's in every single one of these parts of these fractions. But I noticed that the y squared and the y down here, if I were to multiply those, that would give me a y cubed. And there's a y cubed up here that would neatly cancel all of that out. So I'm going to cancel out these two y's down here with the y cubed up here. This is definitely not the only way you could have done it. I could have crossed off these y's instead, but I mean, pick a direction and go with it, right? After you've crossed off as much as you can legally, go through and multiply whatever's left over. So in the numerator, we have a 7, we have an x squared and an x to the 4th, which multiplies to x to the 6th, and all that's left besides that is this y up here. Down in the denominator, there's actually nothing that's left uncrossed out, so that means there's a big invisible 1 down there if you've crossed off everything else. Now, are there any values we need to exclude? Well, I canceled out this x that was in the denominator, so I need to exclude x equals 0. I have to say x does not equal 0 because that would zero this out. And I also crossed off these y's down here, so y also cannot equal 0. So here's another example to give you a little more practice with multiplying rational expressions. Pause the video and try this one out, and you might need a little bit of factoring on this one. The last one we didn't. All right, so let's factor everything that we can. When in doubt, factor it out. The only thing I can't really try to factor is this 3x, so I'm just going to leave that as is. But the 3x minus 3x squared here, I see that I have a common factor of 3x, so don't forget about GCFs, they exist. And I can also take out a negative if I want. May or may not be necessary, I don't know at this point, but I usually take out a negative if I can. So that leaves us with, let's see here, this would be negative 3x squared divided by negative 3x. That would actually be x. 3x divided by negative 3 would be a negative 1. So I can write this as x minus 1. And now, where else am I going to go here? Let me do this denominator here. Things that multiply to negative 5 and add up to positive 4. 1 and 5 works if I have negative 1 and positive 5. So x minus 1 and x plus 5. And just kind of revisiting what I did up here, you might be wondering, well, why didn't I just take out a 3x instead of a negative 3x? If I took out a 3x, I would have had 1 minus x, which doesn't exactly match x minus 1. So that's another reason I ended up taking this negative out. Now, going to my top right factor here, we have things that multiply to negative 20 and add up to 1. 1 and 20 doesn't work, neither does 2 and 10. 4 and 5 works if I have negative 4 and positive 5. So x minus 4, x plus 5. What can I cancel out now? These 3 x's can cancel, again, cross-canceling, totally allowed if I've got multiplication. X minus 1s are in the same fraction, so that was never a question. And we can cross-cancel these x plus 5, so lots of things canceling out here. What's left over? In the numerator, we have just a negative 1 and an x minus 4, so negative x minus 4. And in the denominator, again, we canceled everything else out there. That's not always going to happen, but it did again this time. Excluded values, though, because we canceled out these x minus 1s, I need x to not equal 1, or else that would make the original undefined. This x plus 5 means we need to exclude negative 5. And this 3 times x means we need to exclude x equals 0. So that also is on our list of don't plug it in. If you're taking the honors version of this course, feel free to move on to the next question and start some division. If you're doing the CP version, we've got one more multiplication example for you. Pause the video and try this one out. All right, so this one, we actually only have one fraction. I guess you have two fractions if you think of this second one as being all this stuff over 1, but we can just multiply straight off the bat if you want, and that would move this big parentheses in with the x plus 2 in a single fraction. You don't really have to do that as a first step, but I just chose to do it. Now, one thing you do need to do is figure out how to factor this x cubed minus 27. So you might remember this is the difference of two cubes. This is a cubed minus b cubed, and here's the shortcut just to review that. So a minus b, a squared plus ab plus b squared. So we have to cube root the first thing to get this a value. Cube root of x cubed is just x. And then cube root the second thing to get the b value. So cube root of 27 gives us 3. And the sign always matches for this first parentheses, so it's negative 3. And then the a squared is going to be x squared, plus ab is going to be plus 3x, and then plus b squared is going to be plus 3 squared, so plus 9. And after we factor this, we just so happen to notice that it's the exact same big parentheses that's in our numerator. So we can cancel out that whole parentheses, which has got to feel satisfying on some level. That leaves us with x plus 2 over x minus 3. And now that we've canceled all this stuff out, you might be wondering, well, wait a sec, are there any values that we need to exclude out of all this? And we've found by doing this over and over again that this tends to have imaginary solutions, but if you don't believe me, we can use the discriminant. So b squared minus 4ac, that would be 3 squared minus 4 times 1 times 9. That would be 9 minus 36, which is going to give us a negative value. So we've confirmed there's no values we need to exclude. So if you're taking the CP version of this, this is the end of part 1 for you. Feel free to pause the video and try out some simplifying and some multiplying. And then when you join us again, we'll tackle some division. Welcome back. If you're rejoining us from the CP Algebra 2 or continuing on from the honors, we're going to do a little division now. The nice thing about division is it's basically multiplication. You might remember when you have to divide by a fraction, the trick there is to multiply by the reciprocal of the second fraction. So basically same, change, flip. So with that in mind, pause the video and see how far you can get on this one. All right, so same, change, flip. That means we keep the first fraction the same, we change the sign to multiplication, and we flip the second fraction. So this second one, we're going to have x squared minus 11x plus 30 over x squared minus 6x. And now it's just a normal multiplication problem. So just like before, when in doubt, factor it out. Let's see what we can cancel out. The 7x can't really do anything there. But down here with the 2x minus 10, we can take out a common factor of 2, and that leaves us with x minus 5. In the upper right, two things that multiply to 30 and add up to negative 11. Let me think. 1 and 30, 2 and 15, 3 and 10. None of this is working. 5 and 6. That works if they're both negative. So x minus 5 and x minus 6. And then for our lower right, we can take out an x as a common factor. That leaves us with an x and a minus 6. So what can we cross off? Definitely the x's. We can cross-cancel those. We can cross-cancel our x minus 5's. And again, we're allowed to do this because this is multiplication going on. So if we wanted to, we could move all these numerators and denominators into one big fraction. And then the last thing, they're in the same fraction anyway, is these x minus 6's. So when the dust settles, we have a 7 in the numerator and a 2 in the denominator, and that is it. This whole thing reduces to a constant, which is kind of wild. We do have to kind of note the things that we've lost along the way, though. So x cannot equal 5 because of this x minus 5. We also don't want 0 for the x, and we don't want x equaling 6 either, because that would also make the original undefined. For this next problem, if you're doing the honors version of the course, feel free to do a little review of AC method and then move on. If you're doing the CP version, we're going to do one more example with division in it and a little bit higher level factoring that it's good to review. So if you're doing the CP version, pause the video and try out this division problem. All right, so same, change, flip. First fraction stays the same. Change this to multiplication. And flipping the second one, we're just going to have 1 over 3x squared plus 5x. And where can we go from here? Well, this 6x squared plus x minus 15 is a little bit tricky to factor. We're going to try to use the AC method on this and see if it works out. So 6 times negative 15, that'll be negative 90 for my AC value. So then just to review this, we're looking for things that multiply to negative 90 and add up to this middle coefficient of 1. Well, let me think. We got 1 and 90, 2 and 45, 3 and 30. What else is in there? Does 4 go into 90? Nope. 5 goes into 90 18 times, but that's not helpful. 6 times 15 is a little bit better. 9 and 10. Oh, how did I miss that? 9 and 10. So if we have negative 9 and positive 10, that would add up to positive 1. So just to review, we're going to split this middle x up into the numbers that we just said with x's on them. So this is going to become a negative 9x plus 10x in the middle. And now we're going to factor this by grouping, by taking a common factor out of the first two and the last two terms. For the first two terms, I can factor out a 3x. That leaves me with 2x minus 3. And for my last two terms, I can take a 5 out of that. That leaves me with 2x and minus 3. Just going back to my original fraction now, this 2x minus 3 can come out as a common factor up here, and we have a 3x plus 5 as the other parentheses. So that's most of what we needed to do with factoring. We do have to factor the lower right, though. For 3x squared plus 5x, all I can think to do there is take out an x, and that leaves us with 3x plus 5, which it turns out is actually going to be enough, because I can cancel out these 3x plus 5's. So when the dust settles, I end up with 2x minus 3 in the numerator, and in the denominator we have 4x squared times x, which is 4x cubed. So what do I have to exclude from this one? Well, we canceled out a 3x plus 5. So if I were to zero that out, we would be subtracting 5 and dividing by 3. So negative 5/3 is an x value we don't want people plugging in here. And how about 0 because of this x cubed? Well, because this x cubed is still very much in our denominator at the end and people know they can't plug in 0 because it's right there, they see it, we don't have to mention the 0 here. We just have this one exclusion. For our final boss battle, we've got some healthcare going on. The total amount, which we'll call E in millions of dollars of healthcare expenditures, is given by this E of t function. This is a crazy rational function here. And the residential population of the U.S. in millions is modeled by this P of t function. And t is the number of years since 2000. So for example, 2005 would be a t value of 5. And this P function is not rational. It's not irrational. It's just a normal linear equation, which is kind of nice. What we want to know is, using technology, we want to estimate the annual healthcare expenditures per resident in 2022. So we've got E gives us the total expenditures. P gives us the number of people. So in a moment, you're going to pause the video and see if you can figure out how much money it costs per person, which is probably going to involve a little bit of division. One hint I can give you before you jump into this, because you're going to be able to use technology for this, it would be a great idea to define each of these functions separately in Desmos, and that'll make plugging in whatever number you're going to plug in a little bit easier. So pause the video and give this one a shot. All right, so go into Desmos here. Let me start by defining the E of t function, and that's going to be, let's see, fraction, so division. We've got 1,11082t plus, let's see, 1,422,329, and in Desmos we don't use commas, and then in the denominator we've got 1 minus 0.002t. So that's my E function, which I'm just going to leave that up there, and I can expand this a little bit so that I can see it a little bit better. And I'll move this over now. Let me do my P of t function as well. So that's going to be 2.515t plus 283.37. Now what do I actually need to do with these? Well, I need to figure out the total expenditures in 2022 and divide that by the total people in 2022. So I need to do E of 22 over P of 22. Since I've defined both of these in Desmos, I can easily plug this in. Let me make a fraction. Up top, I'm going to do E of 22. And in the denominator, we've got P of 22. And then that just calculates it for us, does all the plugging in. That comes out to, let's see here, $11,939.98 per resident. So that's it for our lesson on multiplying and dividing rational functions. Hopefully you can stay healthy and bring this average down a little bit. Till next time, Mr. Sutton signing off.